The iconic Tesla Cybertruck is finally here, and it's got some pretty futuristic engineering involved. Let's go over that right now. Hello everyone and welcome to Full Charge Ahead. I'm Adam, thank you for joining me. Here are some interesting engineering facts. The biggest technological advancement is probably the fact that it uses steer-by-wire technology to steer. What that essentially means is that there's no mechanical link between the steering and the wheels. This allows for a variable steering rack. The steering wheel information gets converted digitally to dual electric motors that turn the wheels. One of the biggest perks of steer-by-wire technology is it allows your truck to turn at a much tighter radius at low speeds. For instance, if you're in a parking lot or in a tight parking space, you can maneuver much easier, like a much smaller vehicle. The steering then becomes much less sensitive at highway or fast speeds, so it's not too twitchy or jerky on the highway. There is also no steering column for additional comfort and safety. This technology has been used for many decades in all major jets, including the F-18, F-22, F-35, and airliners. It has dual electric 48-volt motors to turn the wheels for double redundancy. The two steering motors contain about double the power necessary to turn the vehicle when working in tandem. They normally function as a pair. Since they both function at the same time, you'll always know if one faults out. That way, if one motor, controller, power bus, or an entire side faults out, you'll still have plenty of steering power to pull off the highway and get to safety. Steer-by-wire technology was first introduced in the 1940s, but hasn't been very successfully done by production automakers before. In 2013, the Infiniti Q50 was the first production car to have steer-by-wire technology. It had a traditional steering system as a backup, and it didn't work out very well. Today, the Infiniti Q60 has steer-by-wire technology, but it hasn't been well received for its steering either. The rear wheels on the Cybertruck also rotate about 10 degrees or so to allow, in conjunction with the steer-by-wire technology, about a 17-foot turn radius instead of about 23 for a traditional truck this size. Essentially, it's a truck that turns at very low speeds, similar to a much smaller vehicle. The three 48-volt steering motors, two in the front and one in the rear, are all identical units. If you appreciate this information, please hit like and subscribe. Another noteworthy engineering feat is the 48-volt bus architecture. The traditional voltage for an accessory battery and bus system is 12 volts. 48 volts is 4 times the voltage difference. This creates the opportunity for thinner and cheaper wires because less current is necessary for the same flow. This is because power loss is calculated in Joule's law with the formula I squared R. I, the current in amps, and R, the resistance in ohms, can give you the power loss. By increasing your voltage difference by a factor of 4, you're reducing the amount of current necessary for the same flow by a factor of 4 as well, according to Ohm's law. When reducing the electrical current by a factor of 4, you're reducing the power loss by a factor of 16. Consequently, less copper is needed, with less heat issues, so less thermal insulation, thinner wires, and less complexity. Not only that, using a 48-volt bus system doesn't stress out your accessory battery as much as all the accessories that are now connected to a 12-volt system in a conventional car. Your accessory battery feeds virtually all of your electronics, including your HVAC, your infotainment computer, windows, seats, phone charging, ABS, your steering, airbags, virtually everything. 12-volt has been the standard for the accessory battery for the last 60 years. But there's many more electrical devices and conveniences plugged into your battery than there were 60 years ago. Not all electrical devices and controllers run at the same 48 volts. Some microcontrollers run at 0.7 volts or 1.3 volts, so power converters are necessary. However, since 13% of the electrical components draw about 83% of the power at peak demand, the 48-volt system becomes very beneficial. Whenever you need to boost the truck, there's a switch tank converter that will detect whether you're boosting with a 12-volt source or a 48-volt and adjust it accordingly, so you don't even have to think. The more advanced and sophisticated our cars get, the more we're pushing our 12-volt accessory batteries, which is often lead acid or AGM, even more. It seems ICE vehicles could also benefit from the upgraded 48 volts for the bus. Switching to a lithium iron phosphate battery is one solution for this, but switching to 48 volts is probably even better. Some mild hybrid vehicles have a 48-volt system installed, but they usually have a 12-volt accessory bus as well. Tesla recently sent the designs of how to create a 48-volt bus vehicle to many legacy automakers, including Ford, whose CEO Jim Farley publicly thanked Tesla on X. The thing is, the more companies that switch to a 48-volt bus, the easier it'll be to buy components for this system in high quality in volume with good prices. It is mutually beneficial, however it'll likely take other automakers years to make the switch if they decide to. Tesla thinks this is the future and invites all other automakers to join. And another interesting thing about the Cybertruck is that it has a 1 gigabit Ethernet loop around the inside of the outer shell of the vehicle. This is in place of multiple 500 kilobit max peak CAN bus systems. CAN bus is the traditional system that vehicles use. Etherloop has 200 times the bandwidth. The Etherloop connects all of your high-speed controllers together. It is bidirectional for redundancy and communication. All of the data and communication of the whole truck is combined in this same network, so you can plug in your laptop and get real-time information for all of your sensors and systems. The Etherloop system makes it much easier for all of your cameras and electronics to communicate. It has to be bidirectional to allow your speakers, active road noise cancelling microphones, air suspension cameras, and other electronics to communicate essentially instantaneously. The Etherloop also allows for less packet loss, better latency, and much less point-to-point connection wires. It's Ethernet by name, but not technically in practice. There is thoughtful lumping of functionality between the 48-volt bus system and the Etherloop, allowing for much less complexity and more efficiency. There are 50% more endpoint connections in the Cybertruck than the Model 3. With all of this architecture, the point-to-point connection wires were reduced by 68%, and the high-voltage wiring harness mass was reduced by 84%. This reduces the weight of the vehicle and the cost to manufacture and produce them. Seems like a win-win on paper. Let's see how it works out. If you're not aware, Sandy Monroe, who is a veteran automotive engineer, he's done some excellent interviews lately with Elon Musk and the top engineering team that designed the Cybertruck, and that's where the majority of this information comes from, so it should be quite accurate. Check it out if you want the full length. There's a few hours of info out there, so I'm trying to sum it up nicely. The Cybertruck can charge at a typical V3 supercharger at 250 kilowatts, but the new superchargers that are rolling out, the V4s, it should charge up to 350 kilowatts, according to Lars Moravi, the VP of Engineering at Tesla. Lars says that the Cybertruck can charge from 15 to 85% in under 18 minutes in ideal conditions. This is at the new V4 superchargers. The fact that it can charge this fast is mostly due to its 800-volt traction battery architecture. There are some EVs today that already have an 800-volt architecture for their traction battery, including the Hyundai Ioniq 5, the Kia EV6, the Audi e-tron GT, and the Porsche Taycan. The higher voltage traction battery allows for thinner, lighter wires with less components, and usually these vehicles fast charge faster. The Cybertruck can also natively charge at 4 or 800 volts, according to what supercharger you plug it into. This is because it divides the battery in half for charge cycles. In a 40,000-pound sled-haul tractor pull style towing event, the top trim version of the Cybertruck, which is the Cyber Beast, outhauled a Ford F-350 diesel. That was in second place. Third place was the Rivian R1T, and the Ford F-150 Lightning was last. The Cybertruck has also been shown to beat a Porsche 911 in acceleration tests while towing a Porsche 911. The 845 horsepower tri-motor all-wheel drive trim of the Cybertruck can accelerate from 0 to 60 in 2.6 seconds, which is faster than most supercars in 2023. It is now the fastest production pickup available today, and it even out-accelerates the Ford F-150 Raptor R and the Dodge Ram 1500 TRX. The Cybertruck also has V2L Bidirectional charging. This is not new to the industry, but it is a very welcome addition. This means you can power your house, tools, or charge other EVs with one NEMA 1450 240 volt 40 amp plug in the bed, along with 4 120 volt outlets, 2 in the bed, 2 in the cabin. This allows for 9.6 kilowatts of charging for other EVs. That's amazing! All EVs should have this. Essentially, you can draw 11.5 kilowatts of power out of the vehicle to power your house, or whatever you need to use the juice for. With a 122 kilowatt hour capacity traction battery, you have a lot of power for emergency use or just to have on hand. The battery is a dry cell 4680 with 9% increased energy density, made in Texas, USA. There's also some solid additions like a large rectangular frunk in the front that can hold 2 carry-ons or some shotguns. The cabin is roomy and can fit 5 large adults. The bed size is much larger than the Ford F-150 Lightning, the Rivian R1T, or the Hummer EV. There's a sub-trunk under the bed in the back with a drain plug that you can fill with cold drinks and ice if you want to tailgate. The motorized tonneau cover in the back helps with aero efficiency to keep your range up when the bed's not full. The appearance is very polarizing. It's designed to look very futuristic, like something Blade Runner would drive. The body is bullet resistant, but it can withstand 9mm and 45 caliber rounds out of a Tommy gun. The air suspension has a little over 12 inches of play, allowing for up to 17 inches of clearance for off-road. The air suspension also has active road dampening, so if you're off-road bahawing or crawling or accelerating hard in general, it'll be smooth and settled. With the upcoming range extender, it can increase your range to about 460 miles in decent temps, so you might be able to tow about 200 to 250 miles with heavy hauls of up to 11,000 pounds. The bed can hold a total of 2,500 pounds. The Cyber Beast trim weighs about 6,843 pounds, which is about 65% the weight of the Hummer EV and almost half the battery capacity. The Cybertruck is a much more lean machine than the Hummer EV. It can tow about 23% more and accelerate faster. The Cybertruck has an 8-year, 150,000 mile traction battery and drive unit warranty. Tesla also scaled up the regen braking system for the Cybertruck to absorb as much of the heavy mass of the truck and load as possible when braking. Time will tell how all this works out, but there's some very interesting technology and some of it may guide the future. Just wait till Tesla starts including some of the new battery technology that's being released soon, such as CATL's condensed energy battery. It has nearly the energy density of solid state, but should be available in the immediate future. That's pretty exciting. Tesla is CATL's biggest customer. Thank you for watching and keep cruising!